Hello everyone, welcome to the fourth video lecture of class 9 science. So we were dealing with our first unit, that is measurement. So in the previous videos we have seen or we have learnt about the different physical quantities and their SI units, and after that we even studied about some of the rules for writing the SI units and their symbols. So in this video lecture we will be learning about one of the instrument which is used for measuring length, that is vernier calipers. Okay, in detail we will be learning about its description, least count, zero error, measuring and numerical. Okay, so before going into vernier calipers, so what are the instruments we actually use in our day-to-day life for measuring the length? So commonly we use ruler or scale, and one more is tape, right? Meter tape. Yeah. So these are the two things or two instruments we generally use in our day-to-day life for measuring different lengths, right? Okay. So take an example of your ruler. What is the least measurement you can do using your ruler or scale? For example, you will be using in your classrooms a 15 centimeter scale, right? The same scale you can take and see what is the least measurement you can do using your scale. Can you measure 3 centimeter? Yes? Okay. Then try measure, 1 centimeter. Can measure? Yes. Can you draw a line of 0.5 centimeter using your scale? 0.5 centimeter, nothing but 5 millimeter. Yes, you can do it. Can you draw a line of 2 mm or 2 millimeter? Yes, you can. Can you draw a line of 1 millimeter? Yes, you can, right? Can you draw a line of 0.5 millimeter or 0.1 millimeter? No. So there is a limit to any instrument. Okay, there will be a limit for any instrument. That means it can measure up to some quantities. Below that, you cannot measure the things using that instrument. Okay, so that is called the least count. The smallest length which can be measured by the measuring instrument is called least count. In this we are talking about length. If we are talking about different physical quantity, then it will be particular, you can define the same thing, the least count, as the smallest quantity which can be measured by measuring instrument is called as least count. In this case we are talking about length. If it is mass, it can be even mass, it can be even volume, it can be even temperature, it can be even amount of substance, any kind of physical quantity it can be. The smallest quantity which can be measured by the measuring instrument is called as least count. In your scale it is 1 millimeter. Nowadays the scales will come even with 0.5 mm also, but generally usually the least count of the scale will be 1 millimeter. Okay, we can measure the length of the objects up to 1 millimeter accuracy with this scale. So if any device or any instrument is having its least count as 1 mm, that means you can measure the length of objects up to 1 mm precisely or accurately. Okay. If its least count is 2 mm, you cannot measure 1 mm using that instrument. If any scale is given with the least count 1 centimeter, you cannot measure accurately the length 0.5 centimeter. So the least count says that will be the least value or the least amount of quantity you can measure using that measuring instrument. Okay. So other instruments. So we said up to 1 millimeter we can measure using our normal ruler. So there are other instruments to measure the smaller lengths like vernier calipers, which is in the first figure. So its least count is 0.1 mm. That means you can measure up to 0.1 millimeter. And there is one more instrument called screw gauge, whose least count is 0.01 millimeter. That means you can measure the lengths up to 0.01 millimeters. Okay. The first one is this one. This one is vernier calipers. This one is screw gauge. The first one and the second one. Okay. Moving on. So what is vernier calipers? We are going to see in detail now. So this is the figure of vernier calipers with proper labeling. Okay. So the vernier calipers consist of a thin, long steel graduated in centimeter and millimeter called main scale. Okay. See carefully the red line which I am drawing. This thing, which is a thin, long, straight steel scale. It's like your normal steel scale. Okay. Which you will be using in your daily life. It is similar to that. That is called as main scale, and you can see it will be calibrated. Graduated means it will be marked in centimeters and millimeters, and it is called as main scale. The two ends of the main scale, an upper and the lower jaw, are fixed perpendicular to this bar. So you can see there is something called this lower one and the upper one. They are fixed to this main scale. Okay, they are fixed to the scale, the steel scale which is in between. So they are called as fixed jaws because it looks like jaws. That's why it is called as jaws. Okay. They are fixed jaws because they are fixed to the steel scale. The next one is, to the right of the fixed jaws, a slider with an upper and a lower movable jaw. See, this and this are the jaws, and it is fixed to a something like this, an extended part. So that is nothing but a slider. Okay, which you can move like front and back. You can move. The slider can be moved. The slider can be moved or fixed to any position using a locking screw. You can see there is a locking screw also. So three parts we have studied. One is main scale, which will be graduated in centimeters and millimeters, and lower and the upper jaws, which are fixed to this main scale, and these jaws are fixed with movable slider, okay, which can be moved or stopped using a locking screw. Okay, then the vernier scale is marked on the slider. So we said there is a slider which can be moved, right? So here if you see, there are some markings on it. So this is nothing but the vernier scale. So in a vernier calipers there will be two scales. One is main scale, another one is vernier scale. In main scale there will be measurements in centimeter and in millimeters. Okay, and there will be something called vernier scale where you will be having number from 1 to 10. Okay, vernier scale you will be having numbers from 1 to 10. So this slider is nothing but the vernier scale. The lower jaws are used. We said there are two jaws, right? One is upper jaw, another one is lower jaw. Why there are two different kinds of jaws? You can see the upper jaw is different when compared to the lower jaw. So why they are given? They have two different functions. The lower jaws are used to measure the external dimensions of the object. For example, you are given with a sphere. If you want to find out the diameter, then we will be using the lower jaw, because external thing you are finding out. Okay, then there is something called upper jaw, which is used to measure the internal dimensions of the objects. So you are given with a cup. Okay, you want to find out the inner diameter of that cup, then you will place that cup outside this jaw like this. Okay, outside this jaw, then you will find out the inner diameter of the given cup. So these two has got different functions. Okay, so the lower jaw is used for measuring the external dimensions, the upper jaw is used for measuring the internal dimensions of the object. Okay, the thin bar attached to the right side of the vernier scale is used for measuring. Here there is one stick kind of a thing which is coming out of this. If you see here at the end, okay, the rightmost, there is a stick kind of a thing will be there, a thin bar, it is a thin bar which is used for measuring the depth. Okay, if you are given with a cup, you have to calculate the inner diameter, then we will be using the upper jaws. If you are asked to find out the outer diameter of the cup, then you will be using lower jaw. If you are asked to calculate the depth of that cup, then we will be using the thin bar at the right. Okay, right side of the vernier calipers. So these are the different parts, and this is the description about the instrument. Okay, so how actually we use vernier calipers? The first step in using the vernier calipers is to find out its least count, range and zero error. So first thing we will be finding out is least count. So what is least count? We have already learned it. So in this case, this is an instrument for measuring the length. So we can define it as the least count is the smallest measurement or smallest length which can be measured using the vernier calipers. So how to calculate that? There is a fixed formula for that. Least count, which is in shorthand it is written as LC, which is equal to value of one smallest main scale division divided by total number of vernier scale division. This is the formula. The least count of the vernier calipers will be equal to value of one smallest main scale division to total number of vernier scale division. Okay, the main scale division will be in centimeters, further divided into millimeters, like your normal ruler. Okay, the value of the smallest main scale division is 1 millimeter, as it is there in your ruler. Okay, in the vernier scale there will be 10 divisions. I said the vernier scale will be having numbers from 1 to 10. So there will be 10 divisions. So the least count will be 1 millimeter divided by 10. Right, value of one smallest main scale division is 1 millimeter and total number of vernier scale is 10. So 1 millimeter divided by 10, which is equal to 0.1 millimeter. In centimeter, whenever you write, it will be 0.01 centimeter. Okay, so this will be the least count of a vernier caliper. Okay, the second thing which we will be calculating is zero error. So what is this zero error? How actually we calculate this? Unscrew the slider and move it to the left so that both the jaws will touch each other. Okay, both the upper jaw and the lower jaw will be touching each other. You have to make it in such a way that both the jaws are touching, and then check whether zero marking of the main scale coincides with the zero marking of the vernier scale. So we know that there will be two scale, one is main scale, another one is vernier scale. So whenever you are bringing it to such this condition, you have to check whether main scale 0 and vernier scale 0 are they coinciding. Okay, if not, there can be three situations occurring. One is that they will coincide, and another thing is that there is no coincidence. I mean, both the lines will not be a straight line. There will be two different cases in that also, which we'll be seeing now. So one thing is that if they coincide like this, the down one is vernier scale, the above one is main scale. 0 of the main scale and the 0 of the vernier scale are coinciding, right? They are next to next. Other divisions are not coinciding, no need to worry about that. But the 0 of vernier scale and the 0 of main scale, they are coinciding. It will be like this. So if it is like this, then we say that there is no zero error. That means there is no error in this instance. If they're not coinciding with each other, that means the vernier scale 0 and 0 of the main scale, they are not coinciding, then we say that the instrument is said to possess zero error. That means there is some error in the instrument. This error can be negative or positive. So first we will be learning about the positive error. In this, the zero error, the 0 of the vernier is shifted to the right of the main scale. As you can see in the figure, the 0 of the vernier scale, that is which is downwards, the scale which is downside is shifted right to the 0 of the main scale, right? They are not coinciding, they are not a straight line. There is something like this. There is a gap between the 0 of the main scale and 0 of the vernier scale. So that we say that this condition is said to call as positive zero error. This is called as positive zero error, or in common we can call it as positive error. Okay. In this case, the reading will be more than the actual reading. So in order to correct this, so this says that there is some error in the instrument. So in order to correct the error, what we have to do, we have to find out which vernier division is coinciding with any of the main scale division. So there will be 10 divisions, right, in the vernier scale, and there will be several divisions in the main scale. So we have to carefully look into that particular division which is coinciding with the main scale. So if you can see in this given picture, the fifth division, the mark 5, is coinciding properly with the main scale reading. So here the fifth vernier division is coinciding with the main scale division. So the positive error is plus 5 into least count. So least count is 0.01 centimeter. So plus 5 into 0.01, which will give you 0.05 centimeter. So whenever you get a positive error is that error when the vernier 0 is shifted right to the main scale 0. So in that case you have to find the coinciding division. Here it is 5. Then after taking, this is a positive error, so plus 5 you have to put, and then you have to multiply it with the least count. So that will give you the value of 0 error. Here it is plus 0.05 centimeter. So if the error is positive, the correction will be opposite of that, that is negative. So 0 error is plus 0.05 centimeter, 0 correction is 0.05 centimeter, minus it will be. Okay, so this is about positive error. So there will be some situation when the 0 of the vernier scale will be shifted left, towards left of the 0 of main scale reading. So in that case it is called as negative error, just opposite of the positive error. Okay, so in order to correct this error we need to find such a vernier division which is coinciding with any of the vernier scale division. So in this given one you can see the 6th division is coinciding with the main scale. So you cannot write it as minus 6. So whenever you are calculating the negative error, you should be very careful. You have to count from backwards, that is from 10. So it will be 1, 2, 3, 4. When you are counting from the 10, it will be 4. Whenever you are calculating a negative error, keep it in mind, you will be counting from 10, not from 0. Okay, so our division here will be the 4th one from the back. Therefore, the negative 0 error is minus 4 into least count, that is minus 4 into 0.01, which will give you minus 0.04 centimeter. Then the correction will be opposite of the error, that is positive. Therefore, 0 correction is plus 0.04 centimeter. So always remember 0 error, 0 correction is just the opposite sign of error, that's it. Okay, in the positive 0 error we will be counting from 0, in the negative 0 error we will be counting from backwards to find out the division which is getting coinciding with it. Okay, so this is about the preliminary things which we need to do before carrying out the measurement. So once you find out the least count and the 0 error and the 0 correction, we will be using it for measuring the different length. Okay, so the step 1 is calculate the least count. We have calculated. Determine the 0 error and the 0 correction. We have done it. Then place the objects between the jaws like shown. You are given with a plate kind of a thing which is placed between the lower jaws. Okay, I'm finding out the outer diameter of this ring, for example. It's a ring or a plate kind of a thing. Okay, I have placed it in the between the lower jaws. Okay, now determine the, so I have zoomed in the main scale, the scales. Okay, the determine the main scale reading, short form is MSR. Okay, here it is how much the green line is showing you, this green line is showing you the value. So how actually we calculate this MSR? Okay, so MSR is that reading which the 0 of the vernier scale will be crossing. This 0, this 0 is of vernier scale. It has crossed this division, right? This division it has crossed. This division it hasn't crossed yet. Therefore, we say that the 0, sorry, not the 0. The main scale reading is 2.2 centimeter. It cannot be 2.3 because 0 of vernier scale did not cross the 2.3. It has crossed only 2.2. So you can write it as 2.2 centimeter. Then determine the vernier scale division which is coinciding. So the red mark over here, you can see this one. This division is coinciding properly with the main scale. So this is the coinciding vernier scale division. How much it is? It is 8. I have written it as 7. It's 8, right? It's 8. Yeah. It's 8. So make it a correction. It's 8. Okay. For example, I have taken it as 7, whatever it is. Okay. So the total reading will be MSR plus VST into least count. Okay. So it will be 2.2 plus, it should be 8. I have written it as 7. Take it as an example if 7th one was coinciding. Okay. 7 into 0.01. So total reading will be 2.27 centimeter. Here it should be 2.28 centimeter. Okay. So this is how we calculate the total reading. Okay. This will be fine if there is no error in this given vernier calipers. If it has got any error, it can be positive or negative. So any error, then we have to calculate the corrected reading. So if zero error, for example, I am taking zero error as 0.03. It's a positive error. So this is for an example. I am taking it as plus 0.03 centimeter. Then the correction will be negative 0.03 centimeter. Therefore, the corrected reading, the formula you can see, total reading plus 0 correction. That will be 2.27 plus minus of 0.03. Okay, so actually you are doing the subtraction. So the reading, the value will be 2.24 centimeter. Okay, so that's how we use the vernier calipers for measuring the different lengths, different small length. Okay, so nowadays digital vernier calipers are available, which has got digital display on the slider, which calculates and displays the measured value. You need not do all this whole calculation. It will just calculate and tell you everything. Okay, it will display everything. The user need not manually calculate the least count and the zero error, etc. So you need not to calculate least count, all the zero errors and all. So you can see the slide. There are two jaws as usual. There is a thick steel, which is nothing but our main scale reading and main scale, and there are two jaws, regular, like in the case of normal vernier calipers. And instead of vernier scale, you are given with the digital display, right, where directly you can read the reading. Okay, so nowadays these are used because whenever we calculate using normal vernier calipers, there are chances that we do some mistakes while looking into the digits or the divisions which are actually coinciding. We sometimes may make mistakes because they are very tiny. It is very difficult to point out which division is actually coinciding with the main scale. So this digital display will easily give, there is no difficulty in calculation also. You can just write down the value directly. Okay, nowadays these vernier calipers are used. Okay, so based on your calipers, we will be having some numericals also, like calculate the correct reading. If the main scale reading is 8 centimeter, vernier coincide is 4, and positive zero error is 0.05 centimeter. It's just you have to apply the formula. Correct reading is equal to MSR plus VST into LC plus zero correction. You need to just remember this formula. MSR plus VST into least count plus zero correction. Okay, this will give you the corrected reading itself. So the MSR reading, MSR is 8 centimeter plus VST, the coincide, vernier coincide is 4, then the least count will be 0.01 centimeter and the zero correction will be, this is a positive error, that means error will be plus 0.05, correction will be minus 0.05, therefore totally it will be 8 minus 0.01, then that is 7.99 centimeter. Okay, just a small formula you need to remember. The other one, which is talking about the negative error, The main scale reading is 8 centimeter and the vernier coincide is 4 and the negative zero error is 0.02 centimeter. The calculate the correct reading. Correct reading will be equal to MSR plus VST into LC plus 0 correction. So here MSR is 8 centimeter, VST is coinciding division, that is 4 into 0.01, that is your least count, plus, so it is a negative zero error. Negative zero error, that means the correction will be positive, therefore it is plus 0.02 centimeter. So totally you will get it as 8 plus 0.04 plus 0.02, which will be giving you 8.06 centimeter. So that's about instrument vernier calipers. So we have studied its description, different things like zero error, least count, and then we even studied how actually the measurements are done using the vernier calipers and different parts of vernier calipers. And nowadays digital calipers are used, so that there will not be any difficulty in finding out the readings. And then we have studied how actually the corrected readings can be calculated using one small formula. So this is about vernier calipers. So in the next class or in the next video we will be studying about another instrument which is used for measuring small lengths, that is screw gauge. So I hope you understood, and after this there will be some set of questions I'll be providing you. I hope you all will do it with sincerity, and you will go through the textbook also once again after going through this video. Thank you.